Welcome to section 3. We'll be looking at how to balance redox equations. Oxidation number is a number given to elements in both the free and the combined states according to a set of rules. Free state here means the non-bonding states, like when they are just on their own as an atom, where you have just a sodium plus chlorine. In these states, they are free. But when they now combine to form sodium chloride, you say that the sodium and chlorine are in the combined states. So in the free state, they are on their own and the oxidation state is usually 0. But when they now combine, the oxidation state either increases or decreases. The rules include Rule 1. The oxidation number of free neutral atoms in uncombined state is given as 0. Example, magnesium is equal to 0, Cl2 is equal to 0. In their uncombined states, the oxidation number is 0. Rule 2. In a simple ion, the oxidation number has the same sign and value as the charge on the ion. For a simple ion, or in a simple ion, the oxidation number has the same sign and value as the charge on the ion. Take for example Zn2+. The oxidation number is +2. For O2-, the oxidation number is -2. Rule 3. The sum of the oxidation number of the atoms in a formula equals the net charge of the formula. Example, sodium chloride, that is sodium +1, chlorine -1. Overall oxidation number is +1 - 1, which is equal to 0. So for sodium chloride, the overall charge is equal to 0. But the individual charges, for sodium it is +1, for chlorine it is -1, meaning that the oxidation state is +1 and -1. Adding it up, you have +1 plus -1, which is the same as +1 - 1, and it is 0. But another example here, SO4 2-, it has a charge 2-, meaning that the overall oxidation number of SO4 is -2. In that case, the oxidation number of sulfur plus that of oxygen should give you -2. Rule 4. Oxidation number of hydrogen in all compounds except metal hydroxide is +1, and that of oxygen in all compounds except peroxide and the OF2 compound is -2. So oxygen is always -2 except in the peroxide or in the OF2 form or combined form, while hydrogen is always +1 except in metal hydroxides. I have a question here. Assign oxidation numbers to the following: Fe2+ plus Cl2 to give you Fe3+ plus Cl-. Answer: there is change in oxidation state for Fe, that's ion, from +2 to +3, while chlorine moved from 0 to -1. So the oxidation number of chlorine is 0 at this stage and -1 at this stage. For ion Fe, it is +2 at this stage and +3 at this state. You can now try this on your own. KClO3 to give you KCl plus O2, and also 3Cu plus 8HNO3 to give you CuNO3 bracket 2 plus 2NO plus 4H2O. A redox equation is of little value if it is not balanced. At this level, There are two main ways of balancing a redox equation. These are 1. The half-cell method. 2. The oxidation number method. However, only half-cell method will be discussed since students tend to mix them up when discussed simultaneously. This means that we'll be discussing only the half-cell method of balancing a redox equation. The half-cell method. Balancing a redox equation with the half-cell method is short and straightforward. It goes with the following rules. Rule 1. Write out the half-cell equation for the oxidation and that of the reduction, respectively. Rule 2. Balance both reactions separately with respect to the atoms. Rule 3. Balance each reduction and oxidation with respect to charges. So first you balance with respect to atoms, then you balance with respect to charges. Rule 4. Balance the half-cell equation with respect to the charge coordinated. And then rule 5. Add the two half reaction to get the net reaction. So after balancing the two reactions, that's the oxidation and reduction, you add up the two half reaction to get the net reaction. Example 1. Balance the following redox equation. SN2 plus H plus MnO4 minus to give you SN4 plus Mn2 plus H2O. Step 1 says separate the reaction. You separate it into oxidation reaction and reduction reaction. For oxidation, you have SN2 plus to give you SN4 plus 2 electrons. And that is oxidation. It means that SN2 plus lost 2 electrons to give SN4 plus. On the other hand, MnO4 minus gained hydrogen to give you Mn2 plus H2O, and that is the reduction, the reduction part of the reaction. So step 2 says you balance the two reactions, the two half reactions with respect to the atoms. So in this case, you have SN2 plus SN4 plus 2 electrons for oxidation, MnO4 minus plus H plus to give you Mn2 plus 4H2O. So you balance the equation now. You have MnO4 plus H plus. You have that oxygen is 4 on this side. So to make it 4 also, okay, let me use this equation now, this particular equation. Oxygen is 4 here. So you also have to make this side to have 4 oxygen, just like the normal way you balance your equation. So making it 4 means that you add 4 here. And when you add 4 here, oxygen becomes 4, hydrogen becomes 8, 2 times 4, 8. That means 8 should also be here. So when you balance the atoms, you have MnO4 minus plus 8H plus to give you Mn2 plus 4H2O. Now you balance the charges. Okay, start of 10, that's SN2 plus to give you SN4 plus 2E. The equation is balanced. Then MnO4 minus plus H plus 5 electrons to give you Mn2 plus 4H2O. Step 4. 5SN2 plus to give you 5NS4 plus 10 electrons. What is happening here is that you multiply that of oxidation by the number of electrons gained in reduction. We have 5 here, 5 electrons here. So you multiply each of these by 5. That's why you have 5Sn squared. SN2 plus 5SN4 plus 10 electrons, 5 times 2, 10 for oxidation. Then for reduction, you multiply everything by 2, just like we did in oxidation. So you have 2MnO4 plus 2 times 8 is 16, 16H plus 2 times 5 is 10, 10 electrons to give you 2Mn2 plus 8H2O. And this is for reduction. So combining the two half reactions, adding the two half reactions, you have 5SN2 plus 2MnO4 minus plus 16H plus to give you 5SN4 plus 2Mn2 plus H2O. And this is the balanced redox equation. Balance the following redox equation. So this is the equation Na plus 2H plus 2E to give you Na plus H2 plus electron. So you separate them into oxidation and reduction. You have Na will give you Na plus electron for oxidation. Then 2H plus 2 electrons will give you hydrogen, H2, sorry, that's reduction. So in this case, sodium is oxidized while hydrogen is reduced. Step 2, balancing the atoms. You have 1 mole of sodium here, and also 1 mole here. And then you have electron. Then for the redox, you have 2 hydrogen and also 2 hydrogen here. So it's balanced. Step 3, balancing the charges. We applied the same method we used in solving the previous question. The number of electrons in the redox is what you use to multiply the atoms in oxidation, and then the number of electrons in oxidation, you use it to multiply the atoms in reduction. So in this case, we have 2 electrons, so we'll multiply Na plus and E by 2, and then we'll multiply, okay, the number of electrons here is 1, only E minus. So you multiply 2H plus by 2, 2E, and H2 also by 2. So you have 2Na to give you 2Na plus 2 electrons for oxidation. Then for reduction, you have 2H plus 2E to give you H2. Same as here, this is because the number of electrons is 1, so that is why we have the same equation for reduction. Step 4 is now to add up the two half reactions. We have 2Na plus 2H plus to give you 2Na plus H2, and this is the correct balanced equation for the redox reaction. So I have a quiz for you here to balance the following 1 to 3. You can apply the method and the steps we used in solving the 2 examples, and I'm sure you get the answers. Recap. Oxidation number of hydrogen in all compounds except metal hydroxide is +1, and that of oxygen in all compounds except peroxides is -2. Oxidation number of free neutral atoms in uncombined state is 0. In a simple ion, the oxidation number has the same sign and value as the charge on the ion. The sum of the oxidation number of atoms in a formula equals the net charge of the formula. And there are 2 major ways of balancing the redox equation: the half-cell method, which we discussed, and then there are also the oxidation number method. There are 5 rules in balancing a redox equation. First, you write out the half-cell equation for oxidation and reduction separately. Then you balance both reduction and oxidation with respect to atoms, after which you balance with respect to charges. Then you balance the half-cell equation with respect to charge coordinated. Then you add the 2 half reaction to get the net reaction. With that, we come to the end of this section.